it looks like they detected the interstellar visitor, 3I Atlas, that was discovered back on July 1st, 2025, this year.
The latest image captured by NASA's observatories of the interstellar object known as 3I Atlas has reignited fascination across the astronomical community. This is only the third confirmed interstellar visitor ever detected passing through our solar system, following the enigmatic 1I/Oumuamua and the cometary 2I/Borisov. Yet what makes this new release so remarkable is not just its sharpness or its detail, it is the strangeness of what the image appears to show. Unlike anything previously seen, 3I Atlas seems to blur the line between solid and ethereal, between comet and artifact, between the familiar physics of celestial motion and something that appears to defy known explanation. Before we start, hit the like and subscribe buttons for more exclusive news. Captured by a combination of optical and infrared sensors aboard NASA's James Webb Space Telescope and the Hubble Space Telescope, the image depicts an object that seems to shift in brightness and shape even within the same frame. At first glance, it resembles a tumbling icy fragment illuminated by the sun, but a closer inspection reveals irregularities that make it impossible to categorize easily. Its reflective properties don't correspond to those of known asteroids, comets, or icy bodies. The spectrum hints at compounds unknown in our solar system, and its albedo, the measure of how much light it reflects, changes inexplicably from one observation to another. Astronomers have long prepared for such encounters since the discovery of interstellar objects became a new frontier of astrophysics. The detection of Oumuamua in 2017 opened the door to speculation about non-natural origins, while 2I/Borisov, discovered in 2019, reassured scientists that some interstellar wanderers were more conventional cometary bodies. 3I Atlas, discovered by the Atlas Asteroid Terrestrial Impact Last Alert System survey in Hawaii, was initially thought to be another fast-moving comet nucleus, but as NASA's telescopes refined their imaging and spectroscopy, it became clear that this visitor refused easy classification. The new image is astonishing in its clarity. It shows an elongated core wrapped in what appears to be a translucent envelope of material, almost like a sheath of vapor, but not one that follows the predictable shape of a cometary tail. Instead, the emission appears organized, bright bands and nodes that pulse in a pattern eerily regular. The structure seems to glow from within, and the distribution of light suggests the presence of internal sources rather than simple reflection. For planetary scientists accustomed to the chaotic, uneven shapes of icy bodies, this degree of symmetry is profoundly disconcerting. One of the most puzzling aspects revealed by NASA's data is how the object interacts with solar radiation. Normally, as a comet approaches the sun, volatile compounds vaporize, creating jets that push the object slightly off course, a predictable form of non-gravitational acceleration. 3I Atlas, however, exhibits acceleration that seems to fluctuate independently of its distance from the sun. The new image, when overlaid with motion tracking, suggests subtle distortions in its apparent trajectory that can't be fully accounted for by outgassing, radiation pressure, or gravitational interactions. To many observers, it looks almost as if the object is actively correcting its path, a notion that evokes both wonder and unease. The material composition inferred from the imaging is equally perplexing. Spectral analysis reveals sharp absorption lines corresponding to silicates, organics, and possibly metals, but the ratios do not match any known natural combination. The most unusual finding involves peaks in the infrared that suggest lattice structures, highly ordered, repeating patterns that could indicate crystalline compounds formed under precise and stable conditions, unlike the random molecular chaos typical of natural ice or rock. This hints at either a completely novel form of mineral formation in the interstellar medium, or, as some whisper in hushed tones, something engineered. Yet what makes the image so compelling is how it seems to capture not just an object, but a phenomenon. The glowing bands that ripple across its surface appear dynamic, even in still frame. NASA's image composite, created from multiple exposures over a short time, shows these bands shifting subtly, as if the surface were oscillating in response to internal energy. Scientists are reluctant to use words like artificial, but even the most conservative voices admit the behavior resembles a controlled emission rather than random activity. In some wavelengths, 3I Atlas appears almost invisible, ultraviolet and radio scans reveal only faint traces, suggesting that its outer layers might absorb or scatter radiation in ways we've never seen before. This selectivity is what truly confounds physicists. How can an object reflect visible and infrared light so clearly while nearly vanishing under other parts of the electromagnetic spectrum? One hypothesis involves exotic carbon structures capable of manipulating radiation through anisotropic reflection. Another speculates on magnetic shielding, though such mechanisms would normally require an energy source. NASA's image release was accompanied by a brief statement, emphasizing that the data remain preliminary and that the apparent anomalies could arise from calibration artifacts or complex scattering effects. However, among independent astronomers and citizen scientists, the discussion has moved far beyond technical caveats. The resemblance of the banded glow to structured emission patterns has drawn comparisons to everything from pulsars to propulsion system. What unsettles many is that the geometry of the glow, concentric ellipses aligned along the axis of motion, suggests a degree of organization inconsistent with random natural processes. Even more intriguing is the way 3I Atlas appears to interact with its environment. Dust particles in its immediate vicinity display unusual charge distributions, deflecting and clustering in patterns observed by the Parker Solar Probe as it passed within observation range. Instead of forming a diffuse halo as they do around comets, these particles seem to align, forming thread-like structures extending several thousand kilometers. The image released by NASA captures a faint outline of these tendrils, illuminated faintly by the object's inner glow, giving the impression of a cocooned entity moving through interstellar space. The implications stretch far beyond the object itself. If 3I Atlas truly exhibits properties that violate known models of celestial mechanics and material composition, it forces a reconsideration of how interstellar objects form and survive their journey between stars. The densities and temperatures of interstellar space make such preservation improbable for fragile bodies. For 3I Atlas to have retained such structural integrity while exhibiting internal activity implies either a protective mechanism or a composition radically different from any natural analog. Astrophysicists are particularly intrigued by the suggestion of superconducting properties. Some of the spectral data hint at materials capable of conducting electricity without resistance, even at low temperatures. If verified, this would be the first detection of naturally occurring superconductivity in an extraterrestrial body, an observation that could revolutionize both physics and material science. It could mean that certain interstellar environments facilitate the formation of stable, superconducting lattices through pressures and magnetic fields unknown in our solar neighborhood. There is also a growing discussion about the origin of 3I Atlas. Its incoming trajectory, traced back using orbital mechanics, suggests it may have originated from a region between two nearby star systems, perhaps ejected from a gravitational interaction or stellar collision. However, the precision of its path raises eyebrows. It entered the solar system on a near-parabolic arc that brought it unusually close to the plane of Earth's orbit, a coincidence statistically unlikely. The image's clarity has helped refine models of its motion, revealing perturbations that suggest micro-adjustments along the way, as if it had been subtly steered. In terms of its physical size, NASA's data suggest 3I Atlas measures roughly 200 meters across, larger than Oumuamua, but smaller than most comets. The brightness fluctuations visible in the new image imply a rotation period of several hours, but that rotation seems to accelerate and decelerate irregularly. When light curves are plotted, they show patterns resembling modulated pulses rather than consistent rotation, leading some to theorize about internal gyroscopic forces or even artificial stabilization systems. The surface seems smoother than expected, lacking the rugged topography of typical comet nuclei, though at this distance, even high-resolution imagery leaves room for interpretation. To explain the image's anomalies, several natural hypotheses have been proposed. Some suggest that 3I Atlas could be a fragment of a tidally disrupted planet or moon, its internal structure containing trapped energy or magnetized plasma. Others argue it may be a new kind of interstellar comet with crystalline carbon cores that produce resonant photonic effects. However, these theories struggle to account for the apparent coordination of the glowing bands and the near-uniform heat distribution observed in infrared imaging. Normally, solar heating creates hotspots and asymmetrical sublimation, but 3I Atlas seems to maintain equilibrium across its surface, another defiance of expectation. If you like this video, please give it a like and subscribe to our channel. Also, could you leave your comments below and tell us, what are your thoughts on NASA's new 3I Atlas image release? We want to hear from you. Thank you for watching, and see you next time.